Hello and welcome to Contemporary Math. This is section 2.4, Venn diagrams with three sets. So the first thing we want to do today is learn how to draw Venn diagrams with three sets. So our instructions are construct a Venn diagram illustrating the following sets. So we have a universal set here, and it's the numbers 1 through 15. We have set A, which you can see here, 1, 2, 3, 4, 7, 9, 11. And B, 2, 3, 4, 5, 10, 12, 14. And C is 1, 2, 4, 8, and 9. Now, when we go ahead and make a Venn diagram with three sets, we have the universal set is represented here, and it's just a big box. So all of these numbers, 1 through 15, are going to go somewhere inside this box. Now we have three circles. We'll label them A, B, and C. And if we draw them to create the most possible intersections, we actually get 8 different regions here. Okay, and the regions are labeled like this. So this is region 1, this is region 2, this is region 3, call this one region 4, here is region 5, here's region 6, okay, this one here is region 7, and last but not least we have region 8 out here. Okay, so there's 8 different regions, and all of our numbers are going to go somewhere in here. So when you're doing these types of problems, it's very important to work from the inside out. Okay, so what I mean by that is we're going to go ahead and find everything that belongs in region 5 first. Okay, that's our first goal. In order to do this, you can see that this blue region in region 5 is part of set A, part of set B, and part of set C. So the elements that go in region 5 are common to all three sets. So all you have to do is come over here and we're going to look for elements that are in all three. So I see 2 is in all three. Okay. 4 is in all three. Okay, and so you're just going to have to kind of scour this very carefully, but it looks like 2 and 4 are the only elements that are in all three sets. So let's go ahead and write 2 and 4 right there in region 5. Now you can see 2 and 4 are in set A, 2 and 4 are in set B, and 2 and 4 are in set C. Alright, let's move on. From here, we can go around to all the other regions. So we're going to work our way out, and let's do region 2 next. Okay, so we want right in here. So if we look at region 2, this is everything that's going to be left that's in common to set A and to set B. Now 2 and 4 are common to set A and B, but we've already included them here, so we're just going to look for everything else. So let's just look at sets A and B and find what's left that's in common. So we have 3, and that looks like everything. So we're going to go ahead and put the number 3 right in here. Now we're going to rotate around, and we can hit region 4 next. Okay, so now what we're looking for is everything left that's in common between sets A and C. So here I see number 1, okay, and 9. So we're going to add those in here. Okay, rotating right around, now we're going to get region 6. So this is going to be everything that's left in common between what two sets? Well, sets B and C. So we come back over and look at B and C. And is there anything in common there? No, there's nothing in common because this only has 8 remaining and 8 is not in here. So it's okay to leave a region completely empty. There are no elements here in region 6. From here we just keep working our way out. And so now let's go ahead and get region 1 here. And this is going to be everything that's left in region A. Okay, so here is set A. The only things that are left are 7 and 11. So we're going to go ahead and add those right here. Next, let's go ahead and get region 3 here. And this one's going to be everything that's left in set B. So we have 5, 10, 12, and 14. Lastly, we want to get region 7 here. That's going to be everything that's left in set C, which is the number 8. Okay, so this finishes out our sets A, B, and C. However, it's no guarantee that A, B, and C are going to account for every element in the universal set. So what we really have to do now is cross off anything that we've taken out of the union already. Okay, so we took a 1 and a 2 and a 3 and a 4. We used a 5. Okay, have we used 6 yet? Nope, there's no 6. And so this 6 right here is going to go into region 8. Let's keep going. We have a 7 already used. We used 8 already. We used 9. We used 10. We used 11. We used 12. We have not used 13 yet, so that's going to go out in region 8. We have used 14, but we have not used 15. So 15 needs to go out here as well. Okay, so very important not to forget about that region 8. Go back through your universal set to figure out what should go there. Now one thing you could do is as you're putting all these numbers into the regions 1 through 7, you could be crossing off the elements out of the universal set so that whatever you're left with is going to go outside. Alright, let's move on. In our next question, this is more of an application problem, and we're going to use sets here to kind of compare the different countries, and these are countries that won medals in the 1994 Winter Olympics. And we want to place the actual countries in the correct regions. So right now we're not told which sets these countries belong in. Okay, we're only told how many gold medals they have, how many silver, and how many bronze medals. Now we are going to let set A be countries with more than 7 gold. So we're going to call this set A. Set B is going to be countries with more than 6 silver. So we'll call this set B. And then set C is countries with more than 4 bronze. So make that C there. And remember, this is still our universal set, which would be all of these countries here. Okay. Now with this we can just take each country and place them here. So Norway has 10 gold. Okay. So does Norway belong in set A? Well, yes they do. Okay. We'll just put an N to represent Norway. Okay. Does Germany belong in set A? Well, do they have more than 7 gold? Yes, they do. So Germany belongs here. Russia has 11 gold, so they belong in set A. Italy, more than 7. No, they have 7. They don't have more than 7. And then US 6, Canada 3. So set A is rounded out with N, G, and R. Norway, Germany, Russia. Let's go ahead and define set B here, countries with more than 6 silver. Okay, so looking through this, we have Norway. Germany has more than 6 silver. Russia. Not Italy, not the US, but Canada. Well, more than 6 silver? Nope. So that's it, N, G, and R again. And lastly, set C. This is going to be countries with more than 4 bronze. So again, Norway is there. Germany is there. Russia has 4, that's not more than 4. Italy has 8, so they're more than 4. The US has 2, nope. And Canada is 4, that is not more than 4. So we have N, G, and I. So again, as we do this, we want to start right here in the center with region 5. So which countries are in all 3 sets? Well, we have Norway, Germany, and that's it. So Norway and Germany go right in the center. Now we may want to cross them off because we've already placed them. Now we'll move up into this set. So this is region 2, and it's whatever's left in common between A and B. And here we get Russia. We're going to put Russia up here. Okay, we'll cross off Russia. We'll go around here, A and C. Okay, we've already used everything in A, and nothing is in common with C, so nothing's going to go here in region 4. How about region 6? This is B and C. Okay, nothing in common left between B and C, so we'll move around. There's nothing left in A, so there's nothing to put here. There's nothing left in B, and Italy is in C. So you can see that Italy is in set C, but none of the others. Okay, so we'll cross Italy off here. Now we're left with the United States and Canada. And these two countries didn't make it into any of the categories. So United States is in here, and Canada is also on the outside. Alrighty, so again, the easiest way to do this is just to label your sets here. Go ahead and find which countries belong to which set, and then use our inside-out approach to fill out the Venn diagram. Alright, let's move on. Next we're going to talk about De Morgan's laws and equality of sets. So De Morgan made some very good theories about logic, and a lot of set theory deals with logic. So we're going to use Venn diagrams and region comparison to determine the following. So these are for any general sets A and B. Okay, so we don't really know what's in the sets, we just know they're sets A and B. So we'll call this one A and this one B. And we want to tell if A union B is equal to A union B, and the complement of that is equal to A complement union B complement. And we're going to use region comparison to do this. So in a 2-set Venn diagram, we actually have 4 regions. We label them 1, 2, 3, and 4. So when we have parentheses here, we're going to do A union B first. So A union B means take everything, join them, A and B together. So that would be regions 1, 2, and 3. So we get rid of the sets at this point, and we deal with regions. So we have 1, 2, and 3 in parentheses, and then we have the complement of that. Now the complement is going to say every region but 1, 2, and 3. So everything that's not 1, 2, and 3, and so we're left with region 4. Okay, so if we were going to choose all the elements, we would choose all the elements in region 4. or we can just list region 4 here. Now let's go ahead and compare it to A complement union B complement. So A complement is everything that's not in set A. So set A contains the regions 1 and 2. So everything that's not 1 and 2 is 3 and 4. Okay, we're going to unite that now with B complement, so it's everything that's not in B. So B contains regions 2 and 3, so the regions are 1 and 4. Now if we unite these two regions, we're just combining them, so the union means put them all together without doubling, so 1, 3, and 4. Now in the end, we compare, are we left with the same regions? Well, they're not the same, so these are not equal sets. Okay, let's try our next one. We have A union B complement again. We already did that over here, so that's going to be region 4. And now we're going to do A complement intersects B complement. We already did A complement, and that was sets 3 and 4. And B complement was 1 and 4. Now we're looking for the intersection. Okay, the intersection is which regions do they have in common? Well, it looks like region 4. So now when we compare the two, are they equal? Is region 4 equal region 4? Yes. So these ones are equal. Now, in looking at the form of this, here we have A union B in parentheses complement, and then we're going to say that equals A complement intersects B complement. So one way we can think about that is if we were to sort of distribute the complement to both A and B, like we did here, A complement, B complement, it switches the operation over. So union then becomes intersection. Okay. I want you to try this with 3 and 4. You can go ahead and pause the video, try these two on your own using region comparisons, and then when you hit play, you can check your work. All right, give it a try. All right, so let's check and see how you did. Here we have A intersects B complement, so let's write our regions out. So A intersects B is going to be region 2, and then we want the complement of that, so that's regions 1, 3, and 4. And then we're going to compare it to A complement intersects B complement, which we already did right up here, so that's just region 4. Okay, so are those equal? Nope, you should have gotten not equal there. And let's try our last one. We have A intersects B complement, which we did on this side. So that was 1, 3, and 4. Then we're going to compare it to A complement union B complement, which was right up here. So that's 1, 3, and 4 as well. And are those equal? Well, yes, they are. So logically, again, if we think about distributing this complement into here, we would get A complement and B complement, just like this. And what do you know? The operation, which was the intersection, flips over, okay, to become the union. So it's the same process as we did up here in number 2. All right, so let's go ahead and just formally write out De Morgan's laws now. and see if you can just think about it in terms of what we just discovered. So here, A union B, and then its complement. So we can think, we're going to distribute the complement to both A and to B, and when we do that, we have to flip over the operation. So the union becomes the intersection. Okay. Same thing for this next one. A intersects B, and then the complement. We distribute the complement to A and B, and we flip over the intersection to be the union. Alright, now there's a couple other examples we can do with this. Anything set up in the form where we have one of the operations, complement or union, and then we have the complement on the outside, this process works. So let's think about this. We have the union of A complement and B, and then we're taking its complement. So we're still going to think of distributing the complement to both parts. So in this case, A complement is like a double negative, and so it just becomes A. Here B becomes B complement, and the union flips over to be the intersection. So we can use De Morgan's law to help us find many other equivalent statements, just like this one. Now it turns out we can also take things that are listed kind of like this, A complement union B, and we can rewrite them as a complement. Okay, so it's kind of going backwards. So we can put this into this form right here. So something and then the complement of that. So again, we do the same things here. It's almost like factoring now. We're going to take out the complements. So what would A complement become? Well, just A. And then B would have to become B complement. And what would we do with the operation? Flip it over. Union becomes intersection. All right, let's move on. Now we want to talk about equality with 3 sets. Okay, we're going to do this very much the same way as we did with De Morgan's laws. So let's go ahead and draw out the 3 sets. I've spared you from drawing so far, so we'll see how this goes. Ooh, big circle. Now really make sure you intersect that. Again, it doesn't matter how pretty this is. And let's go ahead and intersect another one. Make sure it intersects to create all your regions. And then we'll end with the universal set on the outside. So go ahead and label your regions just so we can talk about this, and label your sets as well. So A, B, and C. Okay. So it's just a good idea to be able to sketch this just for reference points right here. So again, we're talking about general sets here. And set theory, very similar to order of operations, we're going to do whatever's in parentheses first. So we want to do B union C and list which regions that is. Okay. So B union C combines all the regions in B and C together. So we have 2, 3, 4, 5, 6, and 7. Okay, so there's our B union C. And now we're going to intersect that with A. And A is regions 1, 2, 4, and 5. Okay, so we want to see the intersection is what they have in common. So it looks like they have 2 in common and 4 and 5 in common. Okay, so that would be what the left side of this is right here. Okay, so let's go ahead and do the right side. Make a line here. So we want A intersects B. Okay, so we have to think what's in common between A and B, which regions? Well, right here, 2 and 5. We're going to unite that with A intersects C. So what do A and C have in common? Well, looks like 4, 4, and 5. Now we want to unite these two. Okay, so we're going to take everything. So we have a 2 and a 4 and a 5. Then all we have to do at the end is compare both sides. 2, 4, 5 is equal to 2, 4, 5. And so these two statements are equal. All right, thanks again for watching. That is Venn diagrams with 3 sets. This can also be helpful if you know what elements are in the sets. You can narrow it down to find what regions they are and then determine the elements that way as well. So hopefully this made a little bit of sense to you, and thanks for watching. We'll see you next time.